Okay, these are the lecture comments for tolerances that we went over in class, but I wanted to go over it again and also make this available for those of you who are not here. Okay. When you manufacture something, variation is going to be part of the process. You can't make parts exactly the same every time. There will be variation every time you build something. And it's important to understand tolerances because if you don't, you can't make interchangeable parts. So you can't make parts in advance that work with your machine. So for interchangeable parts to work, you have to understand tolerances. If you have large tolerances, it's going to affect the behavior of your machine or the functionality of your machine. If your tolerances are too wide, it won't work. Wide tolerances are cheap to manufacture. If you have incredibly small tolerances, then your costs are going to be really high. You will have to have a very precise manufacturing setup, which means expensive equipment, and you have to have a quality control system in place to make sure that you understand if you're sending out good parts or not. If you specify a tolerance that's too small, it will incur extra cost without adding value, and that's bad. So don't specify tolerances that are tighter than necessary. This is a quote from ANSI, and it essentially says you will include tolerances in your drawings and dimensions in your drawings. All right, there are a few kinds of tolerances. Wait, what's that say? So the tolerance, you're saying how much variation you're going to accept. That's what this is saying. So if we look at the way we report tolerances, there's three basic ways. We have limit dimensions, we have bilateral tolerances, and we have unilateral tolerances. Let's look at each one more closely. Limit dimensions, let me pull up all the content on the slide. It looks like this. And basically it says if it's equal to or greater than the value 0.125 and equal to or less than 0.126, as long as your part has a measurement there like that, it's good to go. If it's above or below, then you have to throw it away and start again. Bilateral tolerances. Bilateral, just think about plus or minus. It has two directions it can go. It can be above or below by a certain amount. So you have a target and then plus or minus, in this case, 0.03 inches. This is what we will use most often in our class. So you specify a target with a boundary for variation, and I think it shows us this later. Unilateral tolerances, if you look at how this is written, it says minus 0 plus 0.004. That means it has to be 0.5 exactly, or it can go up to 0.504. As long as it's in between those two numbers, we're going to call it good. If it is below 0.5, we have to throw it away. And then there's a little exercise here where it's identifying the different kinds of tolerances. But if you look at the symbols and how they're written, that should be pretty easy to figure out. Okay, the number we see here is the specified dimension, the 1.5, and then the plus or minus 0.05 is the bilateral tolerance. And then this is a slide that discusses the definitions of the limits, but we've already kind of talked about that, so you can go look at these notes. They're posted online. And again, it's still talking about that plus or minus limit. I like this graphic. It says if your target is 1.5, you can go above it by 0.05. So you have an upper limit of 1.55. If it's 1.56 or 1.555, you have to throw it away. Start again. And if it's below by 0.05, then your lower limit is 1.45. So 1.44 is out of spec and you have to throw it away. One of the things we can do to save us time is we can have general tolerances specified for a drawing. So if you look at the stuff on the bottom right, it says linear dimensions. If it is a number with a single decimal place, we are saying that it has a bilateral tolerance of plus or minus 0.02. If we have two decimal places, we're allowing 0.01 plus or minus tolerance. And if we have 3 decimal places, like 1.234, we will accept a plus or minus 0.005 tolerance. This can be specified once in a drawing, and you don't have to refer to it anymore unless you have an exception to these. And it's usually if you have something that requires a tighter tolerance. So in this case, the 3 would refer to the table at the bottom. So it has 2 decimal places. So you're going to say that can be 3 inches plus or minus 0.01 inch. If it's out of tolerance, you throw it away. That's how it works. There are 3 kinds of fit: clearance fit, interference fit, and transition fit. And it really depends on what you're trying to do. If you're trying to have like a wheel that spins on an axle, you use clearance. But if you want the wheel to stick on the axle, you have to use interference. And transition is somewhere in between. And this will be handled mostly as a vocabulary quiz later, but it gives you a couple of examples. Also, maximum and least material conditions, we will make those vocabulary questions. So just make sure you have those written down in your notebook, and you're speaking in allowances there. So I'm not going to discuss that here. I did it in class. This will just be something you need to know for a vocabulary quiz that we'll do on Canvas. Bottom line for dimensions and tolerances: don't dimension or don't require tolerances that are lower than necessary. It makes it more expensive to produce without adding value. And that's the end.